So let's look now at how VM primitives can help this concurrent garbage collection. We're going to start off the same way. We're going to go ahead and take all root objects and go ahead and copy the object over into 2-space. So that's number 5. And so 5 is now here, and again 5 is unscanned. Here's the difference of what we're going to do though. We're going to go ahead and take the page that 5 belongs to, and we're going to mark this as unscanned. That is, we're going to have no read and no write permissions. And this is going to be true for almost all the pages. We'll keep a few pages read-writable, and those are for new objects. So what's going to happen? We're going to have a mutator, and the mutator goes along and accesses an unscanned object. When it accesses an unscanned object now, it doesn't have to actually check to see whether it's unscanned or not, like we used to have to do before we used VM primitives. Instead, it's going to get a page fault, okay? Because unscanned objects live in unscanned pages. Unscanned pages are no read and no write protections. Okay. By the way, how did we go ahead and do this? We did this with, so we're going to get a page fault, which is the fault primitive. So what do we do on a page fault? We're going to go ahead and let the collector handle that. What's the collector going to do? It's going to go ahead and visit the references of the object that is copied to 2-space. So what's going to happen? We've got a fault. The mutator is no longer running, right? It was using 5 because it wanted to do something to 5, okay? And all of a sudden, it stops because we got a page fault. So what's going to happen? We're going to go ahead and the collector is going to copy 4, copy 6. Those are now unscanned. Update the references. So let's say 4 points to 2 and 5 points to 6 and to 4. And once it has scanned all of the objects on this page, it will then go ahead and mark this page as scanned and make it readable and writable. At that point, the mutator continues. It tried to access 5, and 5 is scanned. Whatever the mutator tries to access, it will see it as scanned. Because if it's not, it'll get a page fault and it'll be scanned out from under it. Okay. So whenever it looks, it sees scanned objects, and that's all it sees. A couple questions come up. So one question, how did this turn to be read and write? This is from the unprotected call. Right, so we've called protect in, we've called unprotected, we've called fault. There's actually one more call that's being used, and that is, how is it that the collector could go through each object on each page in this page? How did it have access to 5 here? Because 5 was no read and no write. Right? At the time this was unscanned. It couldn't read and couldn't write that. So how did that work? Well, the way it worked is this is the mutator's address space. The mutator's address space has a collection. Some pages are unscanned and therefore not readable and not writable. Some pages have been scanned and are readable and writable. We also have a separate collector address space. The collector address space is all read-write. These refer to the same physical pages. So you get the same physical pages that can be seen from one part of the address space as possibly read-write or not read-write. And that is the address space the mutator uses. And then there's a second address space that refers to the same physical pages that is all read-write. So this is what the collector is using. So it can easily go through and read the objects on here. So advantage number 1. We have no software check by the mutator on object access. Remember, we used to have a software check that would check to see whether the object was scanned or not. And now we don't have to do that because we're relying on the fact that we're storing unscanned objects in an protected page. Or rather, Really the key is that we know that unprotected pages, everything on it's been scanned. And that's the advantage number one. Advantage number two is that we can actually do a true concurrent garbage collection. So we can have one or more collector threads that are running in conjunction with the mutator. So the mutator is going along doing its thing, accessing objects, reading and writing, doing stuff like that. And the collector thread, each collector thread is going to basically pick an unscanned page, scan all the objects on that page, mark it unprotected, pick another page, and so on. The only synchronization that has to happen is we have to synchronize on the page level. So we need to make sure if we have multiple threads that are choosing a page and scanning, that they don't collide with one another. We also have to make sure that if we get a page fault, that the collector that's dealing with the page that just faulted, there's not a collection already going on. But that's much better than what we had before, where it looked like we were going to have to do, if we wanted concurrency, have to do a lock per object. And that seems prohibitive as opposed to a lock per page. The only other virtual memory primitive we need is, in order to set up these two address spaces, we need map2. So the four primitives we're using are fault, to actually handle the page fault, protect n and unprotect, and map2. And it's nice that we're using protect n, because protect n is cheaper than doing a bunch of protect ones. We just protect a whole range of these, and then we only have to pay for the single TLB.